Okay, today we're going to talk about the value of 1 mole. So 1 mole is like a baker uses a dozen, and a chemist uses a mole. A mole describes, so 1 mole of anything is 6.02 times 10 to the 23rd particles. A lot of times students make the mistake in wanting to use this number. This is Avogadro's number. They want to use it all the time. But you actually only use this number if they ask how many atoms. Because 1 mole of any element has 6.02 times 10 to the 23rd atoms. Or how many molecules? So if you're talking about H2O or ethanol or hydrogen peroxide, those are molecules. And if they want to know how many molecules are in 1 mole of any of those things, water, 1 mole of water, or 1 mole of hydrogen peroxide, 1 mole of any compound, it's still Avogadro's number, 6.02 times 10 to the 23rd. So only when they say how many atoms or how many molecules do you actually need to use this number. And it is always paired with 1 mole. So you can think of this mole as containing exactly that many particles. And it works on ratios. So if I went to half a mole, I'm going to erase this mole. So there's only half. If I went to half a mole and I asked how many particles are in this mole, it would now be half. 3.011 times 10 to the 23rd particles inside this mole. If I went to a quarter of this mole, I would only have a quarter of the original particles. If I went to 1/10 of this mole, so I'm going to erase this mole again, so that only 1/10 is left, just his nose. It would now be 0.6022 times 10 to the 23rd particles inside the mole are left. So you can actually, it's hard to visualize a number this big, but you can visualize the fact that a fraction of a mole is going to equal the same fraction of Avogadro.